Hello students, in this video you will learn about NOR gate, NAND gate, XOR and XNOR gate. Then we'll proceed to drawing logic circuits. Okay. So you already know about OR gate. So how does an OR gate work? When there is any one high input, that is when any input is 1, the output is 1. That is OR gate. NOR gate is exactly the opposite of it. So what is the structure of an OR gate? Suppose there are two inputs X and Y. This symbol is the one which you do for OR gate. Now, when I say it is exactly, NOR gate is exactly the opposite of OR gate, you just have to add a NOT with it. It is a complement. The opposite of OR is NOR. So, this dot, this circle, small circle indicates the complement of it. That is the NOT of OR. NOT plus OR is NOR. Okay. So, instead of X plus Y, you will get the opposite. That is X plus Y complement. So, how does the truth table go? You have 4 inputs 0, 0, 0, 1, 1, 0 and 1, 1. So, X plus Y complement is the opposite of OR. In an OR gate, how is an OR gate given? X plus Y 0, the remaining are all 1s. Whereas in X plus Y complement, it is the opposite of this. So, 1, 0, 0, right? This is for OR gate. So, this is the truth table for a NOR gate. Same way in a NAND gate, NAND is the opposite of AND. So, how do you draw an AND gate? An AND with a NOT is called a NAND. So, X dot Y is AND, X dot Y's complement is NAND. So, how do you draw the truth table? Say for example, you have 3 inputs 0, 0, 0, 0, 0, 1, 0, 1, 0, you have up to 1, 1. So, how is the output in X, Y, Z? Say X, Y, Z. If it is an AND gate, everything will be a 0. Only when all 3 are 1s, output is 1. But when you do the complement of this, everything will be 1 and only this will become 0. So, a NAND is exactly the opposite of AND. So, if you remember the truth table of OR and AND, you can get NOR and NAND easily. Then one more thing, NOR and NAND gate are called as universal gates. NAND and NOR gate are called as universal gates. Why? Because in the absence of a circuit, in the absence of a logic gate like AND or, you can use NOR and NAND. Any kind of circuit can be constructed only using NOR and NAND. So, it can be a replacement for any kind of logic circuit. That's why they are called as universal gates. Okay. Next, we'll see what are XOR and XNOR gates. Right. So, NOR gates symbol is OR with a NOT. Right. Then NAND gate is AND with a NOT. That is the complement. So, A, B is the input. A plus B complement is the output. A, B is the input. A dot B complement is the output. So, how about XOR gate? If A and B are the inputs, XOR gate is represented like this. This is XOR. XNOR symbol goes this way. XNOR is this one. Okay. Now, how about the truth table of XOR gate? XOR gate gives 1 when there are odd number of 1s. XNOR gate gives 1, or you can say when there are even number of 1s, or you can remember as XNOR is the opposite of XOR. That is even more simpler because you just put a NOT for XOR, then you will get XNOR, right? So, how is the truth table for XOR gate? Suppose you have 2 inputs 0, 0, 0, 1, 1, 0, 1, 1. So, look at the input where there are odd number of 1s. So, here there is a 1, here there is a 1. Other places there are no ones. Here there is no 1, here there are two ones, which is even number. So XOR gate will get 1 when there are odd number of ones. So only in these two places there will be 1. The remaining will be zeros. Whereas for XNOR, it will be the opposite of this. Remember this way. This is very easy to remember. So let me show you once again. NOR gate has two or more input signals and gives an output which is A plus B complement. If all the inputs are 0, then the output will be 1. This is called inverted OR. That is the opposite of OR. NAND gate has more inputs and one output signal, and if all the inputs are 1, output is 0, which is exactly the opposite of AND. It is also called as inverted AND gate. In XOR gate, you can use, instead of simply putting a plus, you will give a circle like this, which shows the symbol of XOR, the operation of XOR gate, and it produces a 1 wherever there are odd number of ones in the input. Here there is only 1, 1. Here there is one high input, one high input. So wherever there are one high odd number ones, you will get a 1. XNOR is exactly the opposite of XOR, right? It is a common. So it is A plus with a circle indicates XOR. You complement that, it becomes XNOR. Okay. So this is how it works. Next, let us learn how to draw a logic circuit for a given expression. Now let us see how to draw a circuit for the given expression. Look at this expression, x plus y dot x bar plus y bar. Now you have two terms in this expression. X plus y is the first term, x bar plus y bar is the second term. What does plus symbol indicate? OR gate. What are the two variables? X and y. So give two inputs x and y and put them in an OR gate, because it is plus symbol. Plus symbol is executed with the OR gate. Okay. So put it in an OR gate. What will be the output of this expression? X plus y. So the first part is done. Now this is x bar plus y bar. X bar means NOT gate, x complement, right? So x put in a NOT gate will give x complement. Y put in a NOT gate will give y complement. So x bar, y bar, both inputs are there. You have to put these in an OR gate again. So put this in an OR gate, you will get x bar plus y bar. Okay. So you already have xy here. So usually we will draw this way. Already you have xy, right? So this gives x plus y. When you need x bar and y bar, we will take the input from this x and we will take the input from this y and put it in a NOT gate. This is x bar, y bar. So the line is taken from the existing xy. So this is also right. And put it in an OR gate. This will get x bar plus y bar. So second part is also ready. Now what is left here? Dot. Dot stands for multiplication, which is symbolized by AND gate. Dot for AND. So bring both the inputs and put it in an AND gate, which means you are putting this and this in an AND gate. X plus y dot this. X bar plus y bar. This is how you draw a logic circuit. Now we'll see another example. X bar y plus xy. Let us see how to draw this. X bar y. What is the gate here? AND. So the first part x, y. But you need x bar. So you have to put it in a NOT gate. The complement will give you x bar, y. X bar and y. Now you have two inputs. Put in an AND gate. So you have to draw AND gate here to get x bar dot y. So first part is ready. Second part is simply xy. So x is here, y is here. Take the two lines and put it in an AND gate because it is x and y. X dot y. So second part is also ready. Now the first part plus second part. What does plus stand for? OR gate. So bring these two inputs and put them in an OR gate. So you will get x bar y plus xy. Right? So this is how you draw simple logic circuits. Now I'll show you a gate with an NOR or NAND gate. Say for example, you have x bar dot y bar plus x bar plus y bar. So you have two things. Now, if you remember the De Morgan's theorem, x plus y whole bar is equal to x bar dot y bar. Same way, x dot y whole bar is equal to x bar plus y bar. So, plus y, x plus y is OR, x plus y complement is NOR. So, actually you have x bar dot y bar. Actually you need to draw this. But if you want to draw this expression using a NOR gate, you have to represent this one. X NOR y. So, give x y inside a NOR gate, then you will get x plus y complement, which is equal to x bar dot y bar. The first part is received now. Now the second part, x bar plus y bar. Instead of drawing this, we will put it in a NAND gate. So x, y put inside a NAND gate will give you xy bar, which is x bar plus y bar. Second part is also ready. Now put them in an OR gate. Then you will get the required output. X bar y bar plus x bar plus y bar. So this is how you draw a circuit using NOR gate or NAND gate. So if you look at dot, you should not use NAND because this is the output. So you should see if this is the required output, then what is the input which is needed? NOR gate. So if you have plus here, which means what is the input needed? You need a NAND gate. This is how you have to decide whether you should use a NOR gate or a NAND gate. And you need not do this unless you have a question saying that draw the following circuit using a NOR gate or NAND gate. Otherwise, the same circuit can be easily drawn without NOR or NAND. If you are simply asked, draw a logic circuit for this, say x bar plus y bar, then you can draw the usual method. Put it in a NOT gate, x bar plus y bar, put in an AND gate. Then x bar plus y bar, same x bar y bar, put in an AND gate plus, and both the inputs put together again in an OR gate will fetch you the answer of this expression. But the same expression can be done using NOR gate and NAND gate. Now we'll learn how to find the expression for a given logic circuit. This is very easy. See, look at the first picture. Look at the inputs here. This is A bar, this is B bar. So there are two inputs, A bar, B bar, A complement, B complement. It is put in an AND gate. What is AND gate? Logical multiplication. So the output of this gate will be the first input multiplied by the second input. Okay. Now look at this. This is also AND gate, which stands for multiplication. What are the two variables? C and D. So C multiplied by D. C dot D, that is AND gate. This is how you have to express. Now, both the inputs are put in a NOR gate. What is NOR? Complement of OR. So you have to put this and this in an OR symbol and put the complement of this. So how will you write it? A bar dot B bar is the first input and the second input is C dot D. And both this in a NOR gate. What is NOR gate? Put an OR and complement. This is the expression for this one. And you can even find the complement. So in the previous video, I told you how to find the complement, right? So this will become A plus B dot CD bar, which is A plus B dot C bar plus D bar. So this is how you frame the expression. Even this is okay. This should be okay. But this is the exact way of writing the answer. So it is like break the line, change the sign. So if you do it step by step, I'll tell you how to do it. Plus CD, complement, break the line. So A bar, B bar, whole bar, dot CD bar. And this will be broken like this. Dot C bar plus D bar, because this is break the line again. So this is A plus B dot C bar plus D bar. So either this or this, both are correct. Now look at the second picture. X and Y put in a NOR gate. So X plus Y is OR, X plus Y complement is NOR. Now what is this? Z. So X plus Y bar, Z, both are put in a NAND gate. What is NAND gate? Opposite of AND, complement of AND. So X plus Y bar, get the first input and write the second input Z in a complement symbol and with a complement, right? So how will you write this? X plus Y bar dot Z whole bar. So you have to break the line and change the sign. Break the line in this expression. So this will become X plus Y complement of complement. Wherever you break the line, symbol should be changed. This will remain as Z bar. So complement of complement will get cancelled. So this is X plus Y plus Z bar. This is the expression for this picture. And now the third one, X, Y put in a NAND gate. X dot Y is AND, complement is NAND. Here you have Z. Now both of this put in an OR gate. This is very simple. So XY bar plus Z. That's all. The answer for this circuit. So this is how you write an expression for a given logic circuit. Thank you.